have also investment B, and these are the returns that we're going to get from these investments. All right, so the first question that they're asking us is calculate the expected returns. Okay, so basically we just have to calculate the average return for each of the following. If you remember the formula for the average, you just add the numbers, this formula here. Yes. Okay. This is the formula that we're going to use to calculate the average. The way we've just been calculating averages. Okay. So these percentages, I'll convert them into decimals. 11%, 0.11. 10%, 0.11, 10%, 0.1, 7%, 0.07, 8%, 0.08, negative 6%, negative 0.06, 12%, 0.12. Okay. So we calculate the average. We just add them up, where the numbers up. 0.11 plus 0.07 plus 0.08, you get 0.26. Okay, since there are three numbers there, so we're going to divide by 3, okay? So average is going to be 0.26 divided by 3, 0.08667. So average return for investment A, 0.086, which is the same as 8.6%. And for investment B, same thing, we add all the numbers. And whatever value we get divided by 3. Okay, so we get 0.05, which is the same as 5.3%. A, 8.6%. So these are the average returns for both investments. Okay, are there any questions before I move further? Okay, next we need to calculate the risk of each investment. Basically, we're talking about the standard deviation. Okay, so if you remember, the formula for the standard deviation is this: S equals the square root x minus x bar, which is the average, squared over n minus 1. Okay, this is there how you get the standard deviation. Okay, now notice in this question we don't have probabilities. If there were probabilities, that's what we were looking at last week. Okay, so using this formula there, let me just paste, get a screenshot of it. Okay, so this is the formula we're going to use. Okay, so let me make a small table this side. Okay, so we'll get for each investment the standard deviation. Okay, so we'll start with A. Okay, here our X bar or our average was 0.086. Okay, so you put your average here, all the averages. All right, then what you're going to do, you're going to subtract the return minus the average. Okay, so let me put here, so that these are returns here, this is the average return. Okay, this is for investment A, average returns. We're going to subtract each return by the average so that we get our deviations. Okay, when you're subtracting each individual return by the average, that's what your deviations are. This X minus X bar. Okay, that's what we're doing here. Returns X here, average return X bar. So here we're going to say X minus X bar. So each return subtracted from is average. 0.11 minus 0.086, you get that. 0.07 minus 0.086, you get that. 0.08 minus 0.086, you get that. Okay, these are our deviations. Okay, then the next step is we need to square our deviations. Okay, so this X minus X bar we're squaring each of these deviations. Okay, remember we're just on this numerator here. That's what we're doing so far. We're just on the numerator, X minus X bar squared. So these values 0.0024 squared, get that. Negative 0.016 squared, you get that. Negative 0.006 squared, you get that. Alright. And then you add. Get 0.00087. Okay, so we have done with it. Yes, is there a question, madam? Okay, so n, remember, is just the number of data points. We've got 3 data points, so n minus 1, that is 3 minus 2, that would be 2. N minus 1, which is 3 minus 2. 3 minus 1, you get 2. Okay, remember, n is just the number of data points. Okay, so we're going to divide 0.0087 divided by 2, you get 0.00043. Alright, so here, colleagues, we have done the division. What is left is just to get the square root. Okay, so we're going to say the square root 0.0043 is 0.02083. Okay, standard deviation. Okay, any questions, colleagues? All right, we go to B. B, the average return was 0.0533. Okay, here we have our returns. Average return X bar. Okay, so here we're going to subtract each return from the average. 0.1 minus 0.053, negative 0.06 minus 0.053, 0.12 minus 0.053. Okay, then the next, we need to square each of our deviations. 0.047 squared, this squared, this squared, yes. Okay, you square each of the deviations. Okay, then after you square each of the deviations, add them up. .01947. Okay, this is the part we've done. Okay, I forgot to put sigma here. Okay, the Greek sign sigma. Yeah, just means you add up. Okay, then we divide by n minus 1, so n minus 1 is 2, so divide that by 0.01947 divided by 2. This is our variance. Okay, then to get the standard deviation, you get the square root of the variance. So our standard deviation for investment A is 2%. Okay, 0. If convert this to percentages, that's 2%. And our standard deviation for investment B is 9%. 9.8%. Okay. So between both investments, we can see that investment A is more stable because the standard deviation is not high. Okay, when we're comparing it against investment B. Investment B has got not a very high standard deviation, but it's greater than A's. Okay, so remember how we interpret standard deviation, colleagues, like this. Okay, if it's investment A, our average return was 8.6%. That's what you expect to get on average. Now it's got a standard deviation of 2. So you add a 2 to 8.6. You say plus 2. You get 10.6. 8.6, you subtract a 2, you get 6.6%. So colleagues, this is the range where you can expect to find your returns. Okay, you might not get the average 8.6%. okay, you might get 6%, you might get 10%, you might get 9%, you might get 7%, you might get 8%. But what you can see here is that your returns are not going to be very far from your average. Okay, if your standard deviation is high, it means your returns are going to be very far from your average. Okay, but with a small standard deviation like this, our returns won't be fluctuating. They will be near the average. Okay, yes. Any questions? Okay. Question 3. Find the coefficient of variation. So coefficient of variation, colleagues, for every 1% return we get, it's going to tell us what percent of risk we're going to incur for every 1% return. Okay, coefficient of variation, what percent of risk you're going to incur for every 1% return. Okay, so the coefficient of variation, CV, it is just your standard deviation over the average. Okay, standard deviation over the average. So for investment A, the coefficient of variation, we're going to say what was our standard deviation, 0.02083 divided by our return, average return, 0.086, you get 0.24. Okay, which is telling us for every 1% return, we incur 0.24% risk. Okay. For every 1% return you get, you are incurring a risk of 0.24%. Okay. Where was I kicked out from? I was saying coefficient of variation, it's the standard deviation standard deviations divided by your average or your expected return. Okay, so for investment A, standard deviation 0.02083 divided by 0.086. That's how we got 0.24. Okay, 0.02083 divided by 0.086, you get 0.24. Okay, so basically what this is telling us is for every 1% return we incur or we get, or for every 1% return we incur 0.24% risk. Okay, so we're not incurring a high risk for every return that we get. Alright, now let's go to investment B. Okay, coefficient of variation, as we said, standard deviation, which is 0.09866 divided by the average 1.86. Let me make sure that because it's the highest standard 0.09866 divided by 0.053, 186. So for every 1% return, okay, we incur 1.86% risk. So you're incurring more risk for every return that you get for investment B. Okay. So as an investor or as an investment analyst who's investing money for people, you are going to see that okay, better investing in A because there's not a lot of risk for every return I get. Okay. If you invest in B, the client should have told you that, okay, me, I'm a risk taker and I want you to invest in risk investments. Yes, you can ask a question.